Alright, so the whole idea of this week is we're still going to go on like the volume format of the geometry, but instead of finding the volume of shapes, we're going to find the surface area of two different types of shapes. In the past, you have done surface area of cubes and prisms and pyramids probably, where that you're dealing with the bases being squares, rectangles, hexagons, those types of shapes. Today we're going to deal with the circular shapes. We are not going to deal with the sphere because that's a whole different topic because we don't really know what the net of a sphere looks like. So we're going to deal with the surface area of a cylinder, the surface area of a cone, and understanding the nets because the nets is what helps you solve this. You can do this in two ways. You could use formulas, which I have given you on this page, or you could draw it out and find the area of each and add them together. Typically, I write the areas all out and add them together. I'm going to show you one of both ways for both sets of problems. We're going to do cylinders and we're going to do cones, and then we're going to kind of throw in the nets throughout. So we're kind of going to focus on the two main things, but using the nets. The net is if I would take a shape and completely cut it apart, what would it make? Okay? So this week, you should have already watched the two videos. One's surface area of a cylinder, one is surface area of a cone. They incorporate some volume in there because next week we're going to kind of put it all together. So we're going to do surface area and volume of all different types of shapes. So we're going to put everything we've learned together, and then you're probably going to have some type of mini Google Forms assessment over these topics just to make sure that we're getting it, because it's hard to tell through Zoom if you're getting it or if you're not. As always, if you have questions, send me an email. Reach out. We can do a private Zoom if you need to for help on any of this. So you should have seen the PDF. This is your PDF file. It's uploaded. My hint is always draw the net out. It's a little bit more work, but it's helpful. I've shown you the two formulas that are typical, the two nets, and then you have 4 practice problems that you're going to do before we meet on Monday. Okay, so let's start with a cylinder. A cylinder. If you think about a cylinder, it is made up of two bases that are circles and then something that wraps around it. So if we look at a cylinder is anything that is like a roll of paper towels, cups are cylinders, really anything that's in like that tube format is a cylinder. Okay, if we look at the cylinder, if we think about this, the two bases are two circles. They are identical because it is a cylinder. Your circles are the exact same. So when you're actually solving for it, you only have to find the area of one circle, and then you just put it in there twice. If I would try to cut this shape and peel it open on that dashed line straight up and down, it would fold out into a rectangle, sometimes maybe a square. The length of it would be your circumference or your distance around the circle, and then it would fold into a flat square, or a rectangle, I mean. So your cylinder, if I would transform this out, this is that long piece that wraps around. If you ever have a paper towel roll and you cut it straight down, you open it, you're going to have a rectangle there, okay? Now, on each top, I'm going to have identical circles. They can be in anywhere as long as one's on the top, one's at the bottom. If I would roll this up, it would make a complete cylinder. If I think about this then, I have two things I'm worried about. I'm worried about the area of this circle. That's the exact same as the circle. I'm worried about the area of this rectangular piece. If I was to solve it using just the shapes and I add it all together, that's how I typically do it when I'm not thinking about it. But if you're thinking about it, you can also use the formula. So the first one we're going to do is we're going to kind of go over it as using the different shapes. If I was given a cylinder, usually you're going to have two labels on it. You would have a radius, which is the distance halfway across. Let's say our radius is 5. If our radius is 5 there, it would also be 5 there. Move it a little bit so you guys can see. It would also be 5 here. If my height was 11, that means this is 11. Okay? Now, if I was to find this, I need to know the circumference. That's why if we're using the formula, which I just retract a little. We're just going to use the formula for this one, then we're going to come back and use the other one next time. So if we use the formula, if you look at your surface area formulas, at the top it says surface area of a cylinder. It says 2 times pi times the radius squared plus 2 times pi times radius times the height. This right here is your circumference. This is your area of a circle. You have 2 areas of your circle, and then you're multiplying your circumference times your height to find the area of that rectangular piece. So let's write it out. Surface area equals 2 pi r squared plus, this is your area of a circle. You're multiplying it by 2 because you have 2 circles. This next one part would be 2 times pi times r times height. This is your circumference. I don't think I spelled that right, but that's okay. Okay? And then you're multiplying by your height. Your circumference would be this length right here. Okay? So, from this, we can then plug this in. And plug it into the formula. So if I'm trying to find the surface area, 2 is going to stay the same, times pi is the same. My radius is of the circle, it's 5 squared. So far, all I'm doing is plugging in. Everything is the same except instead of r, I have 5. Then I'm going to add it to 2 times pi is always the same. My radius is still 5, and my height is 11. Okay? So all I've done is plug in. Now I'm going to start simplifying. To start simplifying, I would say that this is 2 times pi times 25. That's 5 squared is 25. Plus, let's say this is 2 times pi times 5 times 11 is 55. You're going to go through and simplify again. Now, it's always easier to combine everything that's not pi first. So when I get this, it would say that this would be 2 times 25 would be 50 pi plus 2 times 55 would be 110 pi. So far all I've done is combine. Then when I simplify, you're either going to get 160 pi units squared because it's flat now, it's two-dimensional. There's no label, I'm going to put units. Or you could plug it into your calculator and you get 50 pi, which would be about 157. I'm going to round to the whole number today to make it as easy as possible. And 110 pi would be 346. And if I add that together, I will get 503 units squared. Okay, so there's more work with this. A lot of it's simplifying. If you really wanted to, you could just plug it into your calculator from this row. So I'm going to show you on my calculator what it would look like. But from this row, you typically could plug it straight into your calculator. Okay, so when you do it, you do 2 times pi is right here, times 5 squared plus 2 times pi times 5 times 11. Okay, I plugged everything in just as it is. My answer would be 502.6, which we estimated to 503. So you could do it in either format if you have a calculator. When you have surface area, you're dealing with pi, you will always be able to use a calculator. Okay? So if that's the step you want to go to, that's completely fine. You can solve from there. If you want to simplify it out, you can solve from there as well. I'm going to give you one more to practice on. This one I'm going to give you the information, and then you're going to solve on your own. So here is our cylinder. Let's say our height is 4. No, our height is 10. Sorry, our radius is 4. Okay, so what I want you to do is take a second and try and plug that in. Okay, so if it is 10, 4, let's make sure you can see it. Remember your surface area formula. Surface area equals 2 times pi times r squared plus 2 times pi times r times h. Okay? Go ahead and pause this video and at least plug in and then reset so we can make sure we plugged it in correctly. Because if you plug it in incorrectly, then it'll be hard to get the right answer. So take a second, plug in what you know. If you haven't plugged it in yet, make sure you pause this right now because we're going to go into it. So you should have now plugged it in. When you plug it in, you know that your height is 10, your radius is 4. So it would be 2 times pi times r is 4 squared plus 2 times pi times r is 4 times your height is 10. That is your formula. If you have not solved it, go ahead and solve it. Remember, you can plug it in from this step or you can simplify it out. I'm going to actually simplify it out once we go through it. But if you just plug it in, that works just as well. So go ahead and do that. Hopefully you have paused the video and solved for it. Remember that you need to have labels. So if you don't have that, go fix that real quick. Alright, so we're going to solve this. So if I would go and simplify it, I would have 2 times pi times 4 squared is 4 times 4, which is 16, plus 2 times pi times 4 times 10 is 40. Okay? Then I'm going to go on and simplify. 16 and 2, that would be 32 pi plus 80 pi. And that would either be 112 pi, or if you actually simplified it out, you would get 352 of that. So we don't have a unit, so we just write units. And we square it because it's surface area. Area is two-dimensional. It is squared. If you actually solved it with pi, you get 351.85837. Keeps going. I'm just going to the nearest whole number to keep it as simple as possible. Okay. What I want you guys to do now is I'm going to give you one more that you are to complete before we meet again. The one I want you guys to do, I'm going to draw it right over here, or I'm just going to write it. So your problem, I'm going to say your diameter is 6. Your height is 3. And let's say they're both in centimeters. Okay, so your diameter is 6, your height is 3. If you would draw this out, diameter is all the way across that 6. Height is 3. Remember, there's no d in this formula. 2 times pi times radius squared plus 2 times pi times radius times your height. So I need to find the radius. You have your diameter, you're going to find radius. So that is something I want you to pause this video, solve. We're going to go over the answer and when we meet on Zoom on Monday. Okay? So that's the first part. We're going to go on to our second goal, which is finding it of cones and understanding the net of a cone. Okay? So make sure you have this down. I'm about to switch the page out. Alright, when we solve for a cone, as you have seen on your surface area formula PDF that is online, your formula is right here. There is much less going on, but there is one new thing that we are going to go over. We're no longer working with a height. When you find the area, the volume of a cone, you're dealing with the height. When you find the surface area, you're dealing with this curvy L. Looks like length, but there's no length in it. It's called the slant height, and that is how much it's actually slanted, which we're going to go over when we draw it. So, when we deal with a cone, surface area we always write as SA. Surface area of a cone would be pi times your radius squared plus pi r times slant length. Okay, right here, that's your area of your circle. This would be the area of that curvy piece. If I have a cone, there is only one circular base. The other piece is going to open up into a different object. So when we open it up, you are going to have, if you think about like ice cream cones, usually they have this wrapping that goes around, and then you're going to have a circle. It is not a triangle. It is just it's like a triangle with like a half semicircle at the top. That is why you're going to deal with your slant height. This is your slant height. Your actual height would be from the tip to the base. Okay, we're dealing with slant height on this, and that would also be this right here. Okay? So, when we do this, let's say this is our first one. Let's say our slant is 9, and our radius is 2. If I go ahead and plug this in, I want you to try it real quick. So go ahead and pause the video and plug it into this formula with what you know. Don't actually solve yet. Okay, you should have paused it and plugged it in. When you plug it in, we know that pi stays the same. Your radius would be 2 squared plus pi stays the same times your radius is still 2. And now your slant length is 9. Okay, when you go ahead and simplify this, you would get pi. So if you haven't, go ahead and solve it actually. Sorry, I forgot to say that. You get pi. Okay, so if you have solved it, you have pi times 2 squared is 4 plus pi, 2 times 9 is 18. This will either be 4 pi plus 18 pi would be 22 pi, or it would equal about 69 units squared. Okay, and again, from this top part, you can plug it straight into your calculator. I'm going to show you right here. Pi times 2 squared This is really fuzzy. One second, guys, sorry. There we go. Okay, when you plug it in, pi times 2 squared plus pi times 2 times 9, you would get the exact same answer. So you can plug it in from the top, or you can simplify it out. This one has much less going on in it, as long as you have the slant height. If you don't have the slant height, that would be something else that you will start doing in high school next year. We're going to have to solve for slant height. We're not messing with that now because I believe that's in the 10th grade or 11th grade when you're actually doing more of the geometry part of math, advanced geometry, that type of stuff. Okay, let's do another one. Let's say that we have this cone. Let's be given a diameter. Your diameter here is 18, and my slant height is 20. Okay. I want you to go ahead and plug it in surface area of this shape. Pause this video. I'm just rewriting the original formula and plug it in. And then once you plug it in, why don't you guys go ahead and actually solve it. So make sure the video is paused, you're plugging it in, and you're actually solving it. Alright, so you should have paused it, you should have solved it. When you plug it in, pi stays the same. We don't have a radius, we have a diameter, but we know that take half of the diameter to get your radius. So half of 18 is 9. Then plus pi times, radius is still 9, times your slant length of 20. And if you actually go ahead and plug this in, it would be pi times 9 squared plus pi times 9 times 20. You're going to have a pretty big answer. Your answer would be, let's say it's 820. We don't have a unit, so we would just write units squared. The biggest difference here, it's not cubed, it's no longer three-dimensional. We were breaking it up and finding the flat area of it. Okay? I'm going to give you guys one to try over this week, and we'll go over it when we meet. I'm going to draw it a little bit bigger so you guys can kind of see why we use a slant height and not a regular height of it. So let's say this one, our slant height would be 10. Our actual height is 8, and our radius is 5. Okay, so you guys can kind of see that this is the Pythagorean theorem going on. I believe it's like 8.02 if it actually works, but this would be how you find a slant height if you don't know what it is. It would be by using the Pythagorean theorem, which we have learned already. We are not going to worry about that. I want you guys to find the surface area of this cone. Your radius is 5, your slant height is 10, your actual height is 8, but that is not actually needed. So I want you to find the surface area of this one for homework over the weekend. So what you're going to finish is this problem. You're going to finish the one we did about the cylinder, find the surface area of that one, and then the PDF online, you're going to do those 4 problems. Again, if you do not have a printer, this is very easy to write out and draw, okay? It's probably easier if you just do that instead of print it. I would make sure somewhere that you do have these formulas because you are going to use them a lot. When I give you guys some like mini open note quiz, you're able to use all this stuff if you have it, which you should have access to it because it's all on your Google Classroom, okay? So make sure this all gets done. If you have questions, let me know, and I will see you guys on Monday. Have a great week, guys. There will be a flip grid coming tomorrow.